right, so back to our set operations. As you can see, we're just a little bit more complicated here. And you could use a Venn diagram, or you don't have to use a Venn diagram. It's really up to you. I just feel like sometimes a visual is a little bit helpful, but if you get your Venn diagram wrong, clearly I think you can understand you've messed everything up. So, our universal set has the elements of the letters that spells math rocks. Set A, and why don't we go ahead and make this set A up here, and let's make this set B and set C. So set B has MASK and set C has COATS. All right, well, let's figure out, first, let's see how many elements or which elements are in all three sets. And so I look at M, no, that's not in all three sets. How about A? Yep, looks like A is in all three sets. All right, how about the T? No. How about the H? No. Okay, so it looks like the letter A, or the element A, is in all three sets. So I noticed that when I was doing this, I have capital letters for my set names, and I probably should have put lowercase letters for my elements. So just to avoid confusion, I'm going to go ahead and use lowercase letters for our elements. All right, so now let's go ahead and fill out these other parts of our Venn diagram, okay? I would like to point out that this region right here would be elements that are in both set A and B, but this region right here would be elements that are in set A and B only. Or we could say they're in sets A and B, but not C. So what elements would fall in that category? Well, it looks like M is in set A and B, but it's not in C. How about the T? No, there's no T in set B. How about the H? Nothing there. All right, so now let's look at this region right here. So we're looking for elements that are in both sets A and C, but they're not in B. So does C have a T? Yes, it does. Okay, does set C have a H? No, it doesn't. Okay. All right, so it looks like when I'm looking at the set A here, that I have one more element, and that is H. That doesn't seem to be in B or C. So if you look at everything that's in set A, it's like we have the MATH, so we're good. All right, so now let's look at this region here. Okay, so is there an element that's in both B and C, but it's not in A? Well, it looks like this S for both of those. Okay, and then it looks like the K is in set B, but it's definitely not in anything else. Okay. All right, so it looks like I've got set B taken care of, and then set C, I have my C. No, I don't. Hold on. That's the name of the set. That's problematic. So I have my C, and then I have my O, and then my A, T, and S are in other sets as well. Okay, so COATS, it's all in set C. All right, let's look at the universal set and see if we're missing an element. So here's my M, A, T, H. I don't see an R anywhere. So O, C, K, S. All right. All right, so let's start with our operations. So I would like A intersect B. So I want everything that's in both A and B. So that would be this right here. And so that would be the set with elements M and A. Okay, how about C union B? So that's going to be elements that are in C or B or both. So that looks like everything that is here. So it looks like we have, let's list the elements in B, M, A, S, K, and then anything else that was in C that wasn't also in B. So that looks like C, O. Okay. Now we're listing the elements that aren't in C. Well, that would be R, because it's not in any of them. H is in A only. M is in A and B, but not C. And then K is in B only. All right, now it's going to get a little bit trickier. So we're looking for the intersection of A and C, and the union of A and C, and the intersection of that with set B. So let's look at what's in A union C. So it looks like I have my M-A-T-H, and then the other letters left over would be this S, C, and then the O. Well, what was in B? M-A-S-K. So is there any intersection between the two? Anything in common? Well, there's an M, A, and there's a S. Okay, so if you'll look at that too on our Venn diagram, if we're looking for A union C, that's this region right here. All the elements are right here. And then if we're looking at set B, we're looking at this. So what did they have in common? What regions did they have in common? This right here. So it shouldn't surprise us then that our elements are M, A, and S. So if it's hard for you to see it on the Venn diagram of the elements that they're asking for, I suggest that you write out the elements and use your set operations there. Okay, let's look at E. What elements, we need to do the parentheses first like any order of operations. What elements are common to both set C and B? Well, it looks like A and S, right? And we want A and S, and all the elements that are in set A. Well, let's start listing all the elements in set A. That's M-A-T-H, and then we have the S. So that can be all the elements that are in set A, or all the elements in the intersection of C and B, or the ones that are both. All right, now we're looking for the complement of A union B. Well, A union B, let's see if I can get my highlighter, maybe just a different color. Nope. So A union B is going to be this region right here. So I want the elements that are not in that region. So don't forget the R, and then we would have the C and the O. All right, next let's look at the difference of A and B. So we're going to look at all the elements that are in set A, but I'm removing from it anything that was in set B as well. So you'll notice that that leaves me with elements H and T. All right, H is kind of a doozy. So we're looking at the intersection of the complement of B and the complement of C union A. All right, so let's list the elements that aren't in set B. That would be R, H, T, C, O. And then let's list all the elements that aren't in the union of C and A. Well, that's only two elements. That's K and R. All right, remember we're looking for the intersection now. So what do these two subsets have in common? We have R, and that looks like it. Okay, after all that, you're like, my gosh, how much worse can this be? Well, I and J are pretty simple. We would like the union of the empty set. Well, the empty set doesn't have anything in it, and set C. Well, that would clearly be just the elements listed in set C. And then we want the intersection of the empty set, and it really doesn't matter what I put here. I could have put something easy or something really intricate, but regardless, does the empty set have any elements in it? No. So what could it possibly have in common with anything here? Well, nothing. So we have the empty set.